Okay, I think conceptually pretty simple video. Um, we mentioned in our last video a limit not existing. We looked at the limit as x approaches 2 of x squared plus 1 over x minus 2, and we observed that the limit didn't exist. And then we went over to Desmos, and we said, well, what's going on here is that 2 is a vertical asymptote. As we approach 2 from the right, the function is crawling up the graph. As we approach 2 from the left, the function is crawling down the graph. And all this video is just a bit of notation. One another way we could express this notion that we're just going up and up and up is that we're going up to infinity. And one way we could express the notion that we're going down and down and down is that we're going down to negative infinity. So we write precisely that. The limit as x approaches 2 from the right of x squared plus 1 over x minus 2 is said to be positive infinity. Just like with numbers, we don't put a plus sign here to indicate positive. We just write the infinity sign. The limit as x approaches 2 from the left of this expression is negative infinity. And aside from this notation, the only thing I really need to emphasize here is that these limits, these one-sided limits, do not exist. I know I've written an equal sign, I've written two equal signs, but this is just notation. This is telling you that the limits do not exist in specific ways. This limit does not exist because instead of approaching a finite number, we're going up, up, up to positive infinity. This limit, the second limit, the left-hand limit, does not exist because instead of approaching a finite number, we're going down, down, down to negative infinity. Because positive infinity and negative infinity are signed, we often can't use this notation with regular two-sided limits. Like, suppose I just have the limit as x approaches 2 of this quantity. Well, I can't say it approaches positive infinity because as we approach 2 from the left, it doesn't. It goes to negative infinity. And similarly, I can't say this approaches negative infinity because if we approach 2 from the right, it doesn't. it approaches positive infinity. Having said that, I thought I was sharing my screen. Having said that, if we had, for example, the limit as x approaches 2 of x squared plus 1 divided by x minus 2 squared. Let's see what happens when we put a square around the denominator. Now, we still have a vertical asymptote. The limit still doesn't exist. But if you approach 2 from the left, you go up to infinity. And if you approach 2 from the right, you go up to infinity. So here's a situation where we have a regular two-sided limit, and we can use this notation. We say that it equals positive infinity. Again, with the understanding that what we really mean is that the limit doesn't exist in a specific way.